You're live.
Hello, everybody, and welcome to episode 4 of our 4-part series. My name is Brad Tallis from Autodesk. I'm here with my buddy Angelo. We are excited because we are actually going to show you how to make the part that we designed in part 1. And then Angelo took the design and put the toolpaths to it in part 2. In part 3, we did a little bit of collaboration, made a couple of changes to it. And part 4 is all about making. And I'm really excited about this because we are showing you how we're going to go from a design in Fusion to a part in our hand, all with one tool using Fusion 360. So, Angelo here, why don't you tell us what we're going to be doing today?
Yeah, all right. Hey, guys. So, if you remember, we designed the spark plug, and I assigned some tool paths to it. And we'll be machining this on our Haas machine. It's the ST10Y. It's a nice, handy little machine. Works out great. And so we're going to be machining today.
Okay, so it looks like we already have some stock loaded up, and let's kind of show the whole process. We're going to take the tool paths from Fusion 360
Yes.
and bring it over to the machine. Is that correct?
Yes, that's correct.
So maybe before we do that, we should talk about shop safety. Make sure when you're in the shop, always wear eye protection.
Yeah, safety glasses
and
first.
Listen to the boss. So
Yeah, all right. So if you remember the other day, we assigned some tool paths. I did change some of the ordering on some things, but so we got the facing, and then we profiled, and came down in these areas here, and I got some threading, and let me open this one up, and here I machined the flats, so you can see that there, and then I just did a circular pattern, so it puts it on both sides. And then after that, I did what we call a spring pass to kind of just clean up all of this area here. After you do some turning and some of the milling features, it kicks up a very slight burr, so I just go trace over it really quick. And then over here, I cut out the bottle opener portion. I'll try to move not so quickly. And you guys, there's some people asking how we move the part. So we've got this 3D connection space mouse. And so it's very similar to just reaching into this screen and manipulating the part. So you can push it away, pull it towards you, flip it, rotate it, and it works out really good. So you can lift up or push down on it, push it away, pan left and right. It's quite cool. So,
love that teamwork, guys.
yeah, so it works out good. So Aaron usually is answering the comments, but he's holding the camera right now. So we're not going to be able to totally be able to answer all the questions. So he's pointing the camera too low.
So with that, feel free to chat in the chat window, but Aaron is our camera guy today. We will take a look at the chat a little bit later. But yeah, we liked hearing from you, so feel free to chat in the chat window. So let's go ahead and move this over and see what we got here.
All right, so I'm just going to post-process. And I've got my Haas ST10Y post. I'll hit OK. Tell it the location. I'm saving it to my USB. And then I save it there. It says, do you want to overwrite? I hit yes, replace it. And then here's our code.
And so this G code came right from the program you wrote in Fusion. And we're throwing it onto the flash drive, and then we're going to take the flash drive over to the Haas ST10.
We plug that guy in. We got this program here. And I'm going to navigate to the USB device. And I'm going to load the program. Copy that over to memory. It loads the program. And then from there, we can run a simulation. So I'll go memory, setting, graph. And then I usually do this when I run the machine to make sure there's no, so backtrack a little bit. So Fusion will post the code, but once you get it to the machine, I also like to run a simulation here just to verify that there's no alarms or anything like that. Sometimes, like on this machine, the live tooling is limited to 3,000 RPM. So I've done things before where it was maximum 4,000 RPM, and you'd post to that machine, but then you come to this machine and it's 3,000 RPM. Maximum, so you'll get like an alarm. So any of those types of things that come up, you'll be able to spot it here. So I'll just hit cycle start, and it's going to run through. I'll turn off optional stop.
I think this is really cool. So it's actually showing a preview of it running through, kind of like what we show in Fusion. And so this is kind of showing the toolpath.
Exactly. You can see a simulation there. It's just the top half is what it's showing.
Yeah, and Angelo, you mentioned you reordered some of the toolpaths inside of Fusion.
Yes.
And what was the reasoning behind that?
Yeah, so like I said a moment ago, when you turn the OD, then you create a thread, and sometimes the thread picks up a little burst, and I come back over and I trace over that just to knock down any burst.
And it was as simple as just basically taking a toolpath and moving it from one location to the other.
Yeah, it's just drag and drop. You just click on the operation and drag it to where you want to place it.
Okay.
And then the only time you'll have to regenerate is if it's dependent on like a rest machining operation. So if you move things around, then you might get the red notification saying you need to
regenerate the toolpaths.
Yeah.
Cool.
Exactly. So that's good there. What else? Have you shown the view of the? I don't know if you can show that, but.
Yeah, so this is, we're at the Technology Center at Pier 9 in San Francisco. So I think Aaron's trying to show you, we're out on the pier. We got a bunch of different machines in here. We got the Haas machines, we've got the Matsura. You can kind of see some of the products that people have made in here. This is a cool man cave, I'll be honest.
Oh yeah, and every Thursday at noon they provide a lunch for everybody. So out here in the drive aisle, they put lunch and everybody just comes and grabs lunch. So we just missed everybody. But we'll be definitely heading there when we're done with this live stream.
Okay.
So I'm ready to go here. I got the stock in there. I'm sticking out 4 inches.
We also put a camera inside, and we were going to post some of that video into the description of this live stream at a later point, just if you wanted to see what it looks like inside the machine. Looks like Aaron's looking at that's a tool changer?
Yeah, that's a turret.
Turret,
yeah. We got 12 tools in there.
Got some good drill bits in there?
Not a drill bit. All right, and we're ready to go. And what I'm going to do, I'm turning op stop on, so it stops at each toolpath we have in here. I'm going to have it stop so you can see step by step and put the camera in there and see what the stock looks like. You can see it's raw stock there. And I'm going to hit cycle start.
You do have noise canceling on. Hopefully it's not too bad.
Hopefully you guys can see that.
Seeing some chips on the window nicely.
Chips and cooling.
Chips and cooling. Let's watch some of the cows go by.
Fresh chips daily. You can see the display.
And what material are we cutting these out of?
So this is aluminum 6061, or maybe some people call it aluminium. 6061 aluminum.
Okay. And that's why we're having to use the coolant, is to help with the chip?
Yeah, lubrication and keep things cool.
Okay.
So at the Pier Technology Center, Pier 9, we use special coolant.
That's right.
Because, there's environmental concerns.
That's correct. Yeah, here at the Pier, we use a special coolant. It's like a mineral oil base. I don't know all the details about it, but it's clear. And if there was like a spill, and we're above water right now, so for the environment, we have to use that special coolant. So we just did the first operation. Let me get the air a little bit. Hope that's not too loud. And we remove that first segment there. And you can see it kind of taking shape. Remove that there. Yep, so that's what it looks like there. And we'll keep going.
So you're having it stop at each operation so we can open it up and kind of show what it looks like, but you're pretty much going operation by operation through Fusion, right? Where you said, okay, we're going to remove a bunch of material, now we're going to come in and do the threading. That's exactly what's happening, right?
Yes, exactly. Yeah. So we're doing it step by step, exactly how we did it in Fusion. And I have what's called optional stop. So Fusion posts the code. There's a in your properties, you can set that to output in an M1. So when it reaches that point, it'll stop to give the operator a chance to look in the machine, make sure that everything looks okay, nothing broke or a dull tool. Also give you a chance to maybe take a measurement and make sure you're looking good there on track. So this next tool is dropped down into the grooves, and so now there's the next phase of it. So we just got a little bit deeper in those grooves, finish those up. And so now it's going to do the single point threading.
I can't get over how fast it threads this thing. Now, you were showing me when we ran this earlier that when you cut threads, it leaves a little bit of a burr on the threads.
Yeah, it always depends on your tool insert geometry, if it's worn a little bit, and material. So it leaves a little bit of a, sometimes you can feel it, but there's threads in there.
So you added an extra tool path inside of Fusion that basically comes back and just runs across the top of those threads.
That's correct. Yeah, I call it a spring path.
So we didn't have that in our live stream earlier. So we did add an extra little tool path in there, but it cleans things up. It makes it look really, really nice. And then he's going to come back and run through the threading again, and it just makes it that much cleaner and that much clearer and easier to thread into the object. So
that's right. So what it's doing now, I'm machining the flats here on this part. And that's you remember the design? It's 300,000. We got our live tool in there.
Trying to get a better
Yeah,
view.
here,
I saw a comment there asking for more machinery footage.
Okay.
It's really hard to capture that with all the tools flying around, but step by step, we're showing
You see the flats.
progress. Yeah. Let us know if the audio is okay, guys. Keep commenting. We're watching. We're watching to see what's happening.
So this was
I think
that
we'll
little
film that.
spring pass. That was just a spring pass.
it wasn't spraying much coolant, so I was hoping.
Okay, so this over here is going to be milling this bottle opener part now. It's a 1/4 inch end mill, so 6.35 millimeters.
Yeah, that's real hard to get.
It's hard to see. Now thinking about it, probably
Try
should
it
have done
out.
it in brass. Probably should have done it in brass so we can run it dry. The next one we'll do so you guys can see. Or maybe we'll figure out how to get it on the camera inside the machine
Yeah.
so that users can see that.
Yeah, like I said, we'll try and post the camera footage from the inside into the description. It might take a day or two, so make sure you come back and check. Also, that's machining. We said this was a 4-part series, but because of your feedback, we've now made it a 5-part series. Somebody asked a question about how did you create the drawing that you used in part 1? So keep an eye out for part 5. I'm going to show how I actually created that drawing with all the dimensions and the notes and the section views, etc. So keep an eye out. I'm not sure if that's next Tuesday. I think it is, but keep an eye out for that. So we listen to your comments, we listen to your ideas, and it helps us make these live streams. So thank you guys for doing that.
All right, so I did a little more milling. So machined the bottle opener portion, and machined the wrench flats, and coming along step by step. Obviously, if I was in a production environment, I wouldn't have it stop at each operation. I would just let it go continuously. We're just stopping it so you guys can see the progress. All right, so now we finished all the work in this front area from here, this front section, and this is all solid stock. So now what we're working on is this portion here where my finger is, and we're going to machine all of that, rough it out, and then finish. And then we're going to leave this still rigid and solid. And then we'll do it in another segment and work on that. And that's a technique I use because obviously if you were to turn all of that, this thing would be flapping in the wind, and then the finished pass wouldn't be ideal.
To say the least.
Yeah.
So you broke it into basically 2 chunks. So we did the front half, and has it machined the flats on the
the wrench flat?
Yep,
It
okay.
has.
So it did the flats, and now it's starting to go backwards behind that, right?
Correct, yes. I'm actually doing it in 3 segments. So the first segment is doing this front part with the bottle opener and the thread and then up to the wrench flats. And the segment I'm working on now is this part where my finger is, where I just turned it down with my roughing turning tool. And then I'll come back in and I'll finish, and let me rotate this around like that. So the next step, it's going to drop down in and start doing those grooves there. And then you can see where the end is, there's a little hole, so that's still going to remain solid.
Okay.
And I'm doing this so it stays rigid, so it remains rigid. No different than if you do the tabbing strategy on a milling machine, where you machine and remove material, but you leave things rigid and solid. And then you remove out here, and then you work your way down to the top, the very last thing to do that. It's a similar technique.
Okay.
Yeah, so now it's machining this area, and I can highlight it here on views. And, so let me change the view to that. So now unzoom a little bit. So now it's machining that area right there.
So it's basically coming in and removing in a couple passes, and then it's going to come in and do these little grooves in the chamfer, it looks like.
Yeah, so that just finished. You want to take a look in there, Aaron?
Wow.
Yeah, finish the grooves there. Looking nice and pretty. And now we're going to continue that same strategy, and now we're going to machine back to the final overall length of the part. So this is just roughing that.
So we're looking at the comments really quick. So Ayal, thank you for being the one that asked that question. So shout out to you. Somebody asked, how much is the Haas machine we're using outside of the home hobbyist? Like, so how much does a machine like this?
This is like, I think he put on there 68,000 US. So the pricing, actually, Haas machines, they have all their pricing on their website. Yeah, this machine is, after you tool it up and everything, it's $60,000, $70,000. But then there's, the entry-level machines. I know that some of the users, I think it was Ayal, I hope I'm pronouncing it right, had asked me what machines you recommend for users. So there's many machines. So you've got opportunities like to get a desktop machine. We've got a new machine coming here. Pier, it's going to be a Bantam Tools desktop PCB milling machine.
Okay.
So they were out here a couple of weeks back and visited the Pier, and so they're sending a machine over for us to use. I don't know exactly the price. I think that's about $6,000.
Yeah, and there's a bunch of different machines out there. There's even the desktop 5-axis Pocket NC. You can make pretty small parts, probably about something like this size with it, all the way up to the Matsura over there. We've got a DMS over here. And what's neat about all of these machines is we test Fusion on all of these machines. So when we write posts and stuff like that, we make sure it works on the water jet. We make sure it works on the Haas and the Tormachs, etc. So.
Yeah, and then going on that, so you can start with the machines that are in the $5,000-$6,000 range, and then there's machines like Tormach. I don't know exact pricing on those.
10 to 20, I think.
10 to 20 or so. And then from there you can get like the Haas Tool Room series machines. Those are like in the mid-20s to low 30s. And they work up from there. And there's other machinery brands too. So it all depends on the budget and your workspace, and you need single-phase power or 3-phase power. Are you doing it at home or do you have a shop? Those types of things. So those are things to consider. So continuing on, so now I'm moving to the final segment here in the back with my fingers. So I roughed out what I could with that tool. And now I'm going to come in and carry on.
Under the watchful eye of Angelo.
Yeah. Yeah, I always like to look at it. You do this long enough and you realize if something goes wrong, then it could be catastrophic if you don't catch it in time. So I always like to be near, but once you've proven it, you're good to go.
Yeah, we did practice yesterday and make sure all the equipment was working with our computers and lights and all that kind of stuff. And I did learn a lot from Angelo, and even like listening to the sound of the machine. And as you have certain diameter material, as it's cutting in, it's actually changing the speed of that material to keep a constant feed rate, so you get really nice finishes. It's pretty amazing. All of this is automated. And I think a total run without stopping is about 5 or 6 minutes for one of these parts, if I'm not
pushing closer to 7
minutes.
8 minutes. We'll take a peek.
But to be able to go from round stock to something like this in just a couple minutes.
So there's that final segment there. Getting a little thin there. It's getting thin, but still successful. There's many ways you can machine a part, and I was just wanting to do this in one operation instead of having to flip it and put in different jaws or hold it in a different fashion. So we do these types of parts, and it all depends on what you're doing, but I like to just try to get things done in one. Obviously, it matters. It depends on what job you're doing and what part and the situation and the quality you need. So this is just a bottle opener that goes in our pocket. So dimensionally, we're not super concerned with accuracy, but so that's kind of why I chose this strategy, just to keep it simple, one shot, done. And then, so next phase here is machine the flats. So where we added that hole for the, here it is. So we added the hole there on the end, and when Brad added that, we didn't put flats, but we decided to add some flats, so when the drill enters, it's starting on a flat face there. So that's what it just did. It just machined the flats. Not a whole lot to see, but you can kind of peek in there. It's hard to tell from the angle it's at. But here's the tool that you use that
Oh yeah, Angelo, I was going to ask you that. So I think I saw a question either on our Facebook group or on one of the other live streams about how do you know which tool, I mean, like, do you order them a certain way? Do you assign them in Fusion to a particular machine? Like, how does that all work?
Yeah, so again, it depends on the environment and the workshop. So I've worked at places, so in my past I was at Tesla, and over there what the guys in the shop did is we had a number of machines, and we'd have, for example, the first 20 or 30 tools all match on all the same machines. So when you program a job, you wouldn't even worry about what your machine, well, you need to know kind of what machine you're putting it on, but then you would program, and then we'd get out to the shop and see what machine's available. So then you post, and then your first group of tools are all the same and they all match. We'd have like a standard tool library that handled 80 to 90% of the jobs or something like that.
Okay.
And so same thing with the lathe. You can take all of these tools and create them in Fusion, and you save it as your library. So for here we have the Pier 9 lathe library. So when I'm programming, I know what machines are available. And then you can add tools, you can remove tools. But so that's kind of how we do it and how some people do it out there in the industry.
That makes sense. Pretty much the standard tools are in the turret, and then so there's a 1/4 inch face mill and a threading tool, and the different kinds of tools you might use constantly.
Yeah, so common tools like you'll have facing and turning, and then threading, grooving, things like that, parting tools. So you'll have the most common tools in the machine. So what we just did is, while we were talking, the machine in the background, it drilled the hole. So here's the drill, and it drilled the hole. You can see a little burr there. So what I do, I use a little strategy. I just cut back, and in the same way I did that spring cast with turning, I do the same thing with the milling tool. And I'll just come back with that 1/4 inch end mill, the 6.35 millimeter end mill, and then face over the top of this to remove the burr. And when I did these before at the SEMA trade show, is we made it so that it can come off the machine and it wouldn't have any burrs. There is just one little bit on the end there, and we'll talk about that when we get those. So now it's going to do a spring cast. I'll turn the coolant off so you can see it if you want to come over here, Aaron. It's kind of going fast, but over the top. So that's it. So just faced over the top. So next thing is going to part it off, and it's going to come in the parts catcher here.
This is our favorite part.
Yeah.
What's that?
This is our favorite part.
Favorite part, yeah. So we're at 8 minutes, 36 seconds now on cycle time here. Sorry, 7:44 is where we're currently at. So now, when I hit cycle start, the part catcher is going to come on. You see it here. Fusion will automatically put the M36 for you, and that's as simple as coming in your toolpath. And if you edit the operation, and right here where my cursor is pointing, use part catcher, you simply check that, and when you post your code, it will put that code in there for you. Super easy. All
Yeah,
right, so go ahead.
I was just going to say, so I see a couple comments where people are saying, could you do this straight all the way through? And yes, you're stopping it every single process so we can kind of show what it's looking like, but you could literally hit run and it would make the whole part and drop into the parts tray, right?
Yes, absolutely. Like I said earlier, I'm running it with optional stop on. So if you look here, it says optional stop. So if that's an M1, so if you look right there, so right there, where the M1 is. So when the machine sees that, it will pause and allow us to open it. So when I disable this, if I turn this optional stop off, now it's off. Now it's on here. Now it's off. It's just like a switch, on or off. So to answer the question, yeah, if I did that, the machine would run from the beginning to the end uninterrupted. But we just did that so we can stop at each operation, and the viewers can see what we're doing in the progress.
Right. Which I think is really cool. And another thing I thought was really neat is the stock actually goes all the way through the machine, and you can advance. Once this is done, you can just pull that stock forward a couple inches. And
yeah, so I have the stock is about that length right now, and different machines come with different things. There's bar feeders that will push the bar from the back. There's bar pullers that you can grab it from the front and pull. It all depends on the machine and the application and how many parts are you making. If you're making 1 or 5 parts, you can just do it by hand. Step on the pedal or move the part, or move the chuck, move the part.
Show that pedal. That was,
there's a foot
pedal.
And I can show you when
the chuck, right?
Yeah, when it's all done, we'll do that.
Open and close the chuck. So when this is done, I'll show you how I do that. So the final operation now, so you can see it's quite thin, but it's still rigid enough. So as I tap on it, there were some concerns. Some viewers put some comments in there about it not working, but it's working just fine. So now, when I hit start, the parts catcher is going to come up. The tool's going to position. Part catcher coolant comes on. Now it drops the part down in here, and there it is. So we open the door and pull it off. So that's the part, and it does leave a little burr on the end. And then what I do is I just take it to, we have a Scotch-Brite wheel that leaves a little burr just on the end, not too bad. And I go to Deburring wheel and I knock that off.
I think that was so awesome that literally in just a few minutes.
Yeah,
7 minutes.
57 seconds right there.
Yep.
The last cycle, 7:57.
We went from round stock, and actually, correct me if I'm wrong here, we designed, when we were doing our live streams, we designed it for like 2-inch stock or something, but when we got here to the shop, they didn't have 2-inch stock, they only had like 1 3/4 or something?
That's right, yeah. So when I did the programming on last Thursday, in my setup, we had 1 3/4 stock. And then when we got here, someone had used the 1 3/4 stock
Go
in
figure.
the shop, but we had a bunch of 1.5" stock. So that's this diameter here. We got some on the floor here. That's 1.5" diameter stock. So what I did in Fusion to accommodate for that is I just I right-click and edit the operation under stock. I just go here and I change it from 1.75 to 1.5, and then I hit OK and I regenerate it. And
all the tool paths regenerate.
Yeah.
And we checked for errors, and
That's right.
So I think that's so cool. You might say, oh, I'm going to use this particular stock, but you get to the shop, you realize you don't have any, but it's that quick to make the change instead of having to reprogram everything.
That's right.
So,
That's right.
And if you look really close at this, I don't know how well you can zoom up on this, but I mean, you'll see the little tiny chamfers that we put in. I mean, this is just gorgeous. I cannot get over how beautiful this looks. The threading. You can see some of the changes that we made in our collaboration live stream, where Angelo said instead of having to use a special tool, let's just turn that fillet into a chamfer, for example. We've got the flats, we've got the hole right there, so we can put it on a chain or something hanging around your neck or whatever.
Yeah.
So we do apologize. We did have some computer issues right at the last minute for doing our drawings. We are going to make a couple of these, and we will pick, I think, 3 people.
One comment from the preceding 3 live streams that we did. So
Right.
if we haven't done the draw yet. If you want to go ahead and leave a comment on parts 1, 2, or 3 of this series, we'll draw them. We'll contact you, and we'll.
Yeah, so we will contact you. Leave a comment in the comments, not in the chat, because we can't do the random draw through the chat. So, let us know what's your favorite thing about Fusion. What would you like to see on future live streams? Other topics, etc. Like I said, we do read them, but I think now we actually have to test this and make sure it works, right?
Oh yeah, we've got some bottles.
Oops, I'm probably right in your way. No product placement here, so
No product placement.
Let's give this guy a quick little try here.
There you go.
There you go, sir. Right off of the machine. I think this is pretty cool. Oh.
Aaron gets one. Oh, his hands are full.
His hands are full. Okay, cheers, sir.
Yeah. Yeah, that works good.
There we go.
So yeah, make sure you comment, like or not, thumbs up, thumbs down, subscribe. Also, to reach us, you can find me on Instagram. My Instagram handle is the True Croatian Sensation. There's an underscore between instead of a space, so the True Croatian Sensation.
And we'll throw that in the description of this live stream. Our emails, etc. Like I said, if you have any questions or comments, definitely put them in there. Hopefully you found this as cool as I do. I kind of geek out on stuff like this. So if you have other things you want to see, I noticed somebody said something about seeing more about generative design. Obviously put those out there. And with that, we want to thank you and keep an eye out for part number 5, where I'll show the drawing, how I created the drawing. You have access to that drawing in part number 1, so if you want to try modeling this yourself, rewatch that live stream on how we actually or how we designed it, and you could make this yourself if you wanted to. So with that, Angelo, this was a blast. I had a lot of fun. Okay. So Aaron, thanks for being the man behind the camera on this one, and we will see you on a future live stream.
Yeah, one more thing really quick. Yeah, if you guys have any questions on anything machining and Fusion, just feel free to reach out, put the questions in the comments, and I'll take a look and do my best to answer those in a timely manner. So we want you guys to be successful with Fusion, and so if you have any questions ever, don't hesitate to reach out.
Beautiful. Thanks,
with
everybody.
that, take it easy, guys. We'll see you.